Well, while the presentation is downloading, I can introduce next speaker, who is Bartosz Balic. He's from Poland, Cifronet, and Cifronet is one of the partners in the Urban Fraud project in charge of what we call the common information space. Okay, that was good timing.
Yes. Thank you. The main goal, one of the major goals of the Urban Fraud project is to deliver an ICT technology to build early warning systems. Because when you look at it, early warning systems are composed of many components that need to work together, that need to communicate. And I'm gonna talk about a piece of software basically that's gonna enable this. So this is the plan of my presentation. After talking about motivation and goals, I'm going to move to requirements that we identified and some conceptual frameworks that we have worked out and design that ultimately led us to the design of the SIS technology, which will be described next. And finally, the use case that we use in the Urban Fraud project is a dike monitoring early warning system. So basically the main goal is to provide a software framework that is going to facilitate basically early warning system at every step of their life cycle, such as the creation of early warning systems, the actual configuration and execution, and then interoperability also between early warning systems. What we mean by early warning systems, so the very first view, a generic view, is that it's in fact any kind of system that is working according to 4 steps. So we monitor something, then we analyze what we monitor, then based on the analysis we make some judgments, and finally the judgments may lead us to taking some action or maybe advising to do something. And of course, example of such a system is environmental monitoring, which we deal with, which is the subject of the project. But actually not also this. We can have very different systems that also fit this cycle, like cloud infrastructure monitoring, for example, or even self-monitoring of early warning systems. And that's in fact the way we would like to approach this, and we would like to in fact have these different early warning systems in Urban Fraud. So when we looked at what existing early warning systems are, basically people have tools, people have existing sources of sensor data, and they apply the tools to analyze data, yes. So they have some legacy stuff, legacy applications that they have. But usually the data doesn't get anywhere more than the local database. It's not exposed in the internet, much less the tools. And then the early warning system may actually involve complex scenarios. So the tools can communicate with each other and then make a kind of workflow, if you like, which realizes some complex early warning scenario. And this scenario involves many different activities, basically. So real-time processing, of course, of sensor data, some kind of decision-making. There's some decision-making logic in it, automatic or maybe by human. We have simulations, of course, compute-intensive simulations for which we need large compute power, and very frequently there is a need to explore what would happen if there was a breach in the dike, for example. And that's what we should support then in the framework. And of course there's the requirement for interoperability between all the different data and tools. And what else is involved? All this works on limited resources. And sometimes there is a need for urgent computing. So we may do what-if scenarios, but if there is an actual breach, we need all the power necessary to deal with this actual threat. Okay, so these are the from the user perspective, more like the analysis of the actual state of matters, and that led us to some system requirements for our common information space, and these are first the need for application integration. For this heterogeneous legacy components, then that would be integration between them to enable to communicate them between each other, and then actually composing them further into higher level. We call that composites. That's a general name to denote business workflows, and then we found actually that the workflows that we have the features of both scientific and business workflows, actually, that workflows that we can identify in early warning systems. But maybe also simpler integration patterns. Then we need dynamic resource allocation management because of the limitation of resources. And metadata is also important, that will be what we find out. And we deal actually with many kinds of metadata, like domain metadata that describes the applications and the data involved. Also metadata describing the system, and also, for example, provenance, which was mentioned in the previous presentation, actually. So now I would like to present how we view all this. Led us to a certain view on early warning system and engineering point of view, a software point of view, let's say. So we view EWS as something composed of parts and appliances. And by appliance we mean basically an application component, such as your legacy simulation that was used to compute some scenarios. And this component is exposed as a service. So, like, for example, a web service, and also wrapped into a virtual image. And then we have a unit like this, a virtual image. We can do a lot of things with that. We can move it around. We can deploy it on different computers, basically. That's the whole thing about the virtualization. So we kind of combine approaches here, different approaches like service-oriented architecture, like virtualization. And we use all those technologies like interface description and WSDL, like XML for data representation, but that should not lead you to the conclusion that we limit ourselves to web services and SOAP. That would not be appropriate for what we would like to achieve. So we provide, apart from web services, we also support many other paradigms and protocols for communication. And then EWS part is a composite which integrates a couple of appliances, basically, and orchestrates data flow and control flow between these appliances, and maybe also other parts, actually. So, what the part is then? We can look at it like this. So it's a kind of service, high-level service maybe, that has some ports, input and output ports, that invokes some appliances, and we actually use service bus technologies to integrate appliances to support many protocols. And then there is a message bus, which is very important, and a part may send messages and receive messages from the message bus, maybe from external components that are not managed by our platform, but that still produce or consume information. And a part has some generic interfaces, so that each part has. And at the moment, we define that it can be started, stopped, and also we define a generic property attention level, which is a kind of global state of the early warning system. I'm going to talk about it in my next slide, one of next slides. And then a part has also a specific interface that it defines its functionality. And I'm gonna have examples of these. One more important thing about parts is that we adopted the approach of loose coupling. So it may be that a part invokes another part, and it's kind of there is a dependency between them. But we actually think it is better that parts only communicate through some kind of message bus, and anyone can basically publish a message to the message bus, and anyone can consume the message from the message bus. And the producers and consumers may not be even aware of each other. And we found it this approach very, very beneficial, and it enables, among others, extendability of the early warning system, because we can add one more part at any time that does something which is already published to the message bus. Something new that we have not thought about earlier. And to do that, we don't have to redesign the whole system, and we don't even have to restart the whole system, because we just start execute the new part, which consumes data which is already there, and does something new with it. And finally, the attention level. Maybe I said alert level. I'm not sure, but we changed the name just recently. So this is attention level, which is another general thing, general concept for every early warning system. So any part basically can send a message about that to change alert level to a certain level, 1, 2, 3, 4. And then we have a generic part, which is attention level manager, that gets all the messages from the other parts and actually makes the actual decision whether the attention level should actually be increased or decreased. And in actual early warning systems, this attention level probably will be mapped to some alert levels that are typical for early warning systems. They mean different things in different early warning systems, but we provide a generic way, the attention level, generic mechanism that any early warning system can use. And then when the attention level is changed, the manager sends information about it to the bus, and again this information, this message, can be received by any part and the part may or may not make use of this information. So a part so the operation of any part may depend on the actual attention level, the current attention level, but it's not necessary. So these were the basic concepts, basically, and then I'm gonna talk about the actual technology, the common information space technology, how we designed this software. So we have basically this technology we have divided into core technology, which is the integration platform that integrates things, and then we have additional services. And at the moment we have two services that extend the core technology, which is service for dynamic resource allocation, of allocation of cloud resources between different AWSs, and a metadata service, basically metadata registry, if you like. And a kind of high-level view on this is the following. And what you can see here is the whole system, actually, in which there are maybe multiple early warning systems, each of which is based on the CIS technology, and also in which there are cloud resources and composites, appliances. These are appliances deployed on the cloud. Then there are early warning systems. Each early warning system is hosted first by most importantly, instance of the CIS integration platform. And we have basically we support many well-known integration technologies such as service bus, enterprise service bus, such as or BPEL for workflows, integration pattern engines, JMS message queue, application containers, things like that. And then on these integration platforms, we also define composites, which basically define the flows between the appliances there. And we can then invoke those composites, and they start running, and they start making they start executing the early warning system scenario. What you can see also in this figure is that we have multiple types of the early warning systems. So, for example, 1 and 2 are dike monitoring, 2 instances of dike monitoring early warning systems. That's one of the added value, by the way, that once we have the technology, appliances and so on, we can make many instances of these for different dikes, for example. And then we have 2 other types of early warning systems. Number 3 encapsulates basically monitoring of other early warning systems, basically. And in this there are its specific composites and also the 2 other CIS technologies that I mentioned. Diarrhea for dynamic resource management and UF2010P07. So the early warning system 1 and 2 would use early warning system 3 as a service, basically, to request resources for dike early warning system. And then there's a 4th early warning system which does the cloud monitoring. And the self-monitoring early warning system will in turn use the services of the cloud monitoring AWS to request some cloud resources and so on. So here we can see the application basically of the same generic technology for different types of systems, each of which nevertheless functions according to the general scheme of an early warning system. And this is another view on this. This is more like functional architecture of our components. So maybe I'm not gonna go into details here, but I'm gonna just repeat maybe the most important information. We have the integration technology, in which we support technologies such as BPEL and CAML for making composites. Then we have UF2010P, the metadata registry, and dynamic resource allocation service, basically. And these manage the appliances which are here. And of course, we provide some bus and on top user interfaces. And I think you're gonna see examples of these in next presentations also. Okay, so here is a couple of more slides about the 3 most important components of the CIS technology. So I mentioned some technologies, some basic functionality, which I basically already explained. So I can skip this at the moment. And just to summarize, what you have to do to create a new early warning system or early warning system template, of which you can have many instances. Using SIS technology is to, when you have your components, your tools, or sensor data sources, you have to adapt them, basically, to communicate with the SIS. And we provide many means of communication. You can expose it as a web service. You can make it communicate through JMS, message queue, and so on. Then you have just wrap the components into a virtual appliance. This is rather well adopted technology by now, virtualization. And then you have to define the composites, such as workflows, that make those appliances work together and make a scenario. Then you deploy it into our containers, into sys containers, and basically then you have a early warning system as a service that you can like invoke, start, and then invoke again to have a second instance. So I'm gonna now present the example. I'm not sure if you already saw this. If not, you're gonna see it again maybe. 3 minutes left. Really, you should have warned me earlier. Yeah, I guess. That's a very late warning. Okay, I'm losing another minute. So this is basically the use case, the scenario that for the dike monitoring early warning system. So we have some sensors, they monitor dikes. Then we detect anomalies in the sensor signals using some AI technologies, artificial intelligence. If we indeed identify some anomalies somewhere, we make further analysis of the probability of actual dike breach, dike failure in the place. When the high risk is indicated, we made even further calculations. We simulate what would happen in terms of inundation if the dike was indeed breached. And then this goes to visualization, which you could see on this multitask table, and maybe there's some further actions involved. So this is the conceptual workflow, and this is how this was implemented in the sys. So basically, we have multiple parts of the early warning system which encapsulate some basic functionalities, such as the flood simulation functionality, and they all communicate through the bus. And I'm gonna just quickly go through the parts one by one. So we have the AI-based monitoring part, basically, which uses the AI appliance, which actually provides the anomaly probability. And then if the probability is high, the part basically sends alert attention level change to the system. Then this attention level change may be picked by another component, the reliable monitoring, which using the sensor data picked from the bus, calculates the probability of dike failure and publishes this probability again to the bus. Then the next part is the flood simulation part, which can be invoked from the multitask table on demand. So a user would define the water levels and so on, and feed it to the simulation. And the part itself would invoke two tools, HR Wallingford hydrograph and DIRFSM, that do the actual simulation. And then the simulation results are fed again to the bus. And just to show you that this part made in sys technology has indeed some complex logic in it. So this is, we use BPEL to do it, to integrate all the components to make data transformations, and to also provide another generic functionality such as asynchronous data asynchronous messages. Then there's the alert level manager part, and then there is one more interesting part which actually shows this extendability feature. Because at some point we made the conclusion that it would be nice to actually store some of the results in some permanent storage. So what we did, we just made another part, an archiver that is connected to a storage, some external storage. And it was enough to turn it on, basically, because it would pick up the already published messages and just store them. So it was quite nice. We didn't have to change any other part of the system. Yes, I'm gonna skip summary, basically. And my last slide is about future work. There's plenty to be done from this point. We just into the first year of the project. We made some initial integration, basically initial tests of the technology, and we still need to implement dynamic resource allocation, self-monitoring, provenance tracking, security, fault tolerance, because of course EWSs need to be running all the time. And last but not least, some auxiliary tools, templates that will make all this more automatic and much more easy. Okay, thank you.
It was a lot of IT, but it's not so strange in the ICT theme. So, any questions? Valeria.
It was a bit too much of the complicated schemes. I get lost after like 5 blocks, and there were like at least 20, 25 in each slide. So my question is: attention something the same what we call alert level? Yeah, is it the same? Because it seems in every work package we call it differently. Okay.
Okay, other questions? If not, thanks very much.